Well, hello, good afternoon to you all, and welcome to this Tools in Action talk in which I will demonstrate 3 possible successors to the Git version control system. My name is Hanno Embregts. I am from the Netherlands. I work at InfoSupport as an IT consultant. Recently, I became an Oracle ACE Associate in the Java category. If you want to find me now or after the talk, I am at HannoTify on Twitter and on Mastodon. I thought it was rather clever, get notified about the things Hanno is doing, but my wife just stared at me, with a blank look in her eyes. But hey, you can find me there. I post about things I like, so mostly Java development, some stuff about version control, and I'm also a musician, so also some stuff about music and how music and software can be combined. If you like that stuff, by all means, give me a follow and we'll connect there. Now, when it comes to version control, I have come a long way. When I was in college, back in 2006, I did version control by email. Who recognizes version control by email? Right? You would send an email to your classmates containing a zip file with your code in it, and the subject would say, latest version, final latest version, really the final version, right? So when I got started in my first software development job, I was really eager to learn a more sophisticated system. But at my first place of employment, they did a version control by USB stick. So I kid you not, there was a central computer centered in the office, and when you were ready with your change set, you just walked over to this computer, plugged your USB stick in, and made sure that you made the merge onto the main code that was on that machine. And you even had to book this machine in our Outlook system for like half an hour, and if you couldn't finish the merge in half an hour, you'd have to walk out again and try again another time, right? Later on, they said, we're moving on to more modern things. Let's try CVS. This was in 2007, so also not very modern. Thank goodness it's 15 years later now, and I've gained some proper experience with Subversion and Git. I even teach a course about Git at InfoSupport. It is a one-day course where I teach our junior developers how to use Git as a developer. We discuss some pros and cons of version control and how the distributed systems compare to earlier systems like CVS and Subversion. And this is actually one of the course slides. It tries to put the version control systems that have emerged until now into perspective with the most modern phone that was available at that time. So, for example, when you look at Subversion right here, published in the year 2000, it relates to the Nokia 3310, right? I had that mobile phone, by the way. Who had that mobile phone? Indestructible, right? Just like Subversion. And CVS, published in 1990, relates to this ancient thing that even has a power plug, right? So both ancient. Now, at the end of one particular course day, a student came up to me with a question, and she said, I really like Git, and thank you for explaining it, but I really can't explain this gap that is here, right? All these version control systems were published in 2005, but what has happened in the past 10 years? Why is nothing happening? And I thought, that's a really good question. I don't have any clue why nothing is happening. So I said, should we just assume that Git will be around forever? And of course, we cannot assume that, because change is the only constant in our industry. So I researched the matter a bit further because I really wanted an answer to her question. And the research got a bit out of hand, and this is why it turned into a conference talk, which is the one you're attending right now. So thank you for being here. Let's find the answer to the question of the student together then, shall we? And to answer the question, we have to discover what factors are influencing the popularity of a version control system. So let's take Git as an example. Why do we think Git became so popular? And I've included a graphic here that calculates or actually estimates the usage of the different systems that were available until 2016. And one thing really stands out in this graph for me is the point where Bitbucket starts supporting Git. Because you had GitHub and Bitbucket. GitHub did Git, Bitbucket supported Mercurial, but by the time Bitbucket said, we cannot ignore Git any longer, we're going to support them, well then Git rose to fame and Mercurial started declining, which is the yellow line here, right? So hosting support is a very important variable in our prediction. Also killer features. I think Git had a few very good features. For example, one of the few distributed systems around that time, which was Bitkeeper, switched to a commercial license. And Git said, no, we want to use this to develop the Linux kernel, so it will remain open source and free to everyone. So that's also a good reason. And speaking of open source, I think Git also really helped speed up the developments in the open source community by being such an open version control system that could be used to do open source development. So these are 3 reasons, I think, why Git has become popular. And I think we must keep these reasons in mind when we think about any new systems that might eventually replace Git. If that even happens, right? I want to add a few more, by the way. I think IDE support is also a good factor that determines the popularity. I really like Git's integration into my IDE, like IntelliJ IDE or VS Code, so a successor must have a certain amount of support in this area to be able to rise to fame. And something I like to call the handicap of the head start, meaning a top product will always have the hardest time staying on top. Just like what happened to Subversion or what happened to Internet Explorer 6 during the browser wars. Or maybe your favorite sports team. They can win the league a few times in a row, but eventually they will be beaten. And I think the same thing holds true for software products. Now, the graph that I showed you earlier, I've tried to put the data into a table. So these are also estimations, but I think this is the way that things were like in the year 2021. So we see that Git is definitely the most used product right now, and there's a long gap until Mercurial and then a few other lesser used systems. And the goal for this talk is to demonstrate 3 possible successors to you and predict which one has the best chance of becoming the top product, right? So that's what we're aiming for today. So let's add some new products, new version control systems. I'll talk about Fossil, Pichel, and Sapling. Let's talk about Fossil first. So this system has been around for a while. It is obviously a distributed system. All 3 of them are actually. And these are the features that Fossil SCM promises. It has an auto-sync mode, which means that it can do automatic pushes after each commit if you configure it that way. But it also has a manual merge mode like Git and Mercurial. It supports operations on multiple repositories, so you can use the Fossil all command to do that. And it preserves all history. So there is no rebase in Fossil. You cannot change history in Fossil like in Git. Also, it would be a very bad name if you were able to change the history. Why would you then call it Fossil? A few quick facts. It is written in C and SQL, and it is the VCS of choice for the SQLite project. It was even written specifically to support development of SQLite. There is free code hosting at Chisel. That is chiselapp.com. But actually, you can just simply host it yourself if you can support an SQLite database and a web server, because Fossil itself stores its commit in an SQLite database. So any hosting space provider could do the job. So it's a single SQLite database file, and it contains relations between check-ins, and this enables Fossil to produce also ancestors and descendants of a check-in. So this is like a double link. In Git, it's always a single link. So let's see this tool in action, right? That's what this talk type is about, and see how Fossil works. Some very basic things, of course. I don't really have time for all of it, but just a few things for you to see. So the first thing we're going to do is make a directory for our demo repository. We call it demo, and Fossil then, if we can then tell Fossil to create a new repo, and we put it in the repo file. Now we have a directory and a repo file. We'll change directories to the demo directory, and then we have to tell Fossil to open the demo.repo file. This connects the repo file to the actual directory right here. And what I really want to do today is write a very basic random number generator. So let's open up VS Code. Oh, not static, random. Let's just print out a random number. And of course, a very good way to generate a random number, as you all may know, is rolling a die, right? Guaranteed to be random. I've rolled a die by chance, so maybe the people in the front row can help me out and tell me what number it lands on. It has a little light in it. Oh, under the chair. And it's not very light in here either, so sorry about that. It says 3. Thank you very much. Thank you very much. So I think today we'll return 3 then. Thank you. Thanks for the assistance, everyone. Let's just run it to be able to see. Yeah, it is working. Very good. So that's good enough for now. This is not a talk about random numbers in Java, right? So let's just add the file to our repo. And then we can ask about changes if we want. What are the changes? Well, we added random.java. Let's commit this then. Commit -m, implement random. And Fossil also comes with a built-in web interface, which I really like. So let's fire up the web interface. And this is how it looks like. It tells us there's an empty check-in with a hash. We have implemented the random in this check-in, and we can actually see the file that is in there. So it's like some sort of a GitHub in a box, right? Because it has a lot of other features. You can add wiki pages and add tickets. So it's like a local GitHub. Actually, when you go to the Fossil website, it runs on the exact same system. So they use their own system to develop their own product, which is something I really like about it. Returning to our slide deck. There we go. Okay, so Git versus Fossil. Like I said, Fossil has a different philosophy. It's like a local GitHub, so that means that it's also tailored to small teams. And the sample project for Fossil is SQLite. I know for a fact that this project is developed by a small team, like 4 contributors, and they know each other on a personal level. So their workflow is based on trust. Whereas with Git, this is completely the opposite. Git's sample project was the Linux kernel with over 5,000 contributors worldwide, so global engagement, and the workflow is built on hierarchy. So I'm not saying everyone should switch to Fossil, but it seems like Fossil is far more well suited for smaller teams, and I don't think all teams that we're currently in are like the Linux kernel team, so that is surely something to think about. Okay, then we are moving on to the next system, which is called Pigul. And the first thing I want to address is the name, because it's hard to pronounce, even for me as a Dutch person. But Pigul is a Spanish word to denote a Mexican species of bird, which is known to do collaborative nest building. And they really like this name because version control systems are about collaboration, right? And building nests and doing things together. They tried to rename it once, and then reverted it back because they liked this name because it was so uniquely Googleable. And yeah, they are right about that. So features that Pigul promises. Well, this is a version control system that is based on patches instead of snapshots. I'll get into that a bit later. But they claim that is simple because of that. It's not the first patch-based system, because in 2003, the Devoxx version control system was released. That is also patch-based. However, that never became very popular, also due to the fact that it was quite slow. And one of the first things that Pigul implemented was to fix the Devoxx performance issue. So some quick facts. It is written in Rust, which is one of the faster languages around because it can tie into low-level OS APIs. And the hosting is available at the Pigul nest, nest.pigul.com, refers to the name of the bird again. And let's zoom in on this unique feature of Pigul, which is the patch-oriented design. So a patch is an intuitive atomic unit of work, and it focuses on changes instead of differences between snapshots, like Git does. And applying or unapplying a patch doesn't change its identity. By contrast, Git doesn't store any patches, it stores snapshots of files and has to compute the differences when they are needed. And in Git, each snapshot has its own identity, whereas with a patch, it can never change. The end result of applying several patches is always the same regardless of their order. So you can apply them in any order, and this is great for cherry picking. Pigul already knows the changes that need to come along and maintains the identity of the change after the cherry pick. So you have no need to manually find any patches here. Like I said, Pigul keeps track of dependent patches. We'll see this in the demo also. Rebase and merge don't exist in Pigul. Applying a patch and its dependencies is just like a Git cherry pick. Conflicts are normal in Pigul. They are modeled as normal states of collaboration, but when you fix it, the fix is just another patch, and that patch can be transferred to other branches or channels, as we call it in Pixel. So that means that once you have a fix for a conflict, you can apply that fix anywhere, and you don't have to do it all over again, like sometimes is the case with Git. And to create an example here of snapshot versus patch, what if my commits were bank transactions? So suppose my initial balance of my bank account is 100 zlotys. Then the snapshot version, so Git would store 100 and patch-based would store plus 100. Then when I get paid by my employer info support, I earn an honest living, right? It could be less, it could be more. 300 zlotys apparently. Snapshot would just store the end result and patch would store plus 300. And then I had to pay the heating bill that I spent this winter, and of course it's become very expensive, so I lose all my money. And the snapshot-based version stores 0, and the patch-based system stores minus 400. And the order, here you can see that the order of the patches wouldn't matter, whereas with snapshots the results would be very different. Okay, so let's put Pixel to the test for a bit, because this is a tools in action talk after all. So I'm in an environment that has Pixel installed right now, and let's init a demo repository again. So it has been created now, and I want to start creating a channel immediately. I'll get back to that in a minute, why I want to do that. I'll just fork it right now. You can just see that we have 2 channels right now, which is equivalent to Git branches, main, and next week. And in this example, we are going to store some movies that I have watched. And the latest movie I watched was a movie by Quentin Tarantino called Inglourious Basterds. So let's save this. And the commit command in Pixel is called record. We are recording patches. And we'll say, watched a movie for grown-ups. If you have seen Inglourious Basterds, you will know why it's a movie for grown-ups. Nothing to record, that's because I forgot to add the file. Sorry about that. And here we get into an interactive edit screen. We can adjust the message if we want. This is the author key. It doesn't store my name. This is a reference to my name. So if I would want to change my name later to Hanno Embregts instead of Hanno, I could do that and nothing would have to change in the history. So very inclusive of Pixel. I like that. And this is the part of the edit screen where you can decide what to add to the commit. You can even leave certain hunks out if you want. But in this case, I just want to add everything. So there we go. And now we are going to watch another movie, but this time my kids are watching. So we're not going to watch anything by Tarantino. They want to watch The Little Mermaid, which was published in 1989, if my memory serves me correctly. We can edit again. You can also use the star here if you want. And then let's record again. But this time we've watched a movie for kids, right? And we can just close down this screen. Let's look at the log. We have an initial patch, a second patch, and a third patch. So 3 patches in total, right? Now we're going to switch channels to next week. And if we get to the log, in this channel, our log is empty, right? That makes sense. Now I want to apply this patch, because I want to demonstrate the concept of dependent patches, right? So I can just apply the patch by providing the hash that I copied from the log. There we go. And now if we come up with the log again, we see 3 patches. So because we applied this patch, Pixel has seen that this is an edit to a file that already existed. In that case, I also need the other patch that actually adds the file. Otherwise, I cannot apply the patch that edits it. So that's very cool. Let's go back to the slides for some more details. So Git versus Pixel, well, that's actually very simple. Git is snapshot-based, Pixel is patch-based. Those are the main differences. Okay, then it's time to dive into the third one, which is sapling. Of course, I could have gone on a lot more time about both Fossil and Pixel, but it's tools in action, so it has to be fast. But there are some links in the final slide if you want to read up about the version control systems and try them out for yourself. if you have a little bit more time. So I'll promise you that. Sapling is a system that was open sourced last fall by Meta, the company behind Facebook, which is why I have included it in this talk. And also, Sapling is a distributed version control system, and it is designed to be scalable and user-friendly. Scalable, in this case, means that at Facebook they have very large repositories, and they didn't manage to make that work with Mercurial or Git, so they created something of their own. It has native pull requests. We'll see that in the demo a bit later. And it integrates with Git and GitHub if you want it to. It's not mandatory, but you can have it integrate with them. And it has an always online approach, which means that it is best suited for situations that you're in the office or in your home office, and you're always connected to your repository. And you can see that in the behavior that it doesn't automatically get all branches from the remote, only the ones that you specify or the ones that are main branches. Some quick facts about Sapling. Like I said, developed and used at Meta. It started 10 years ago, but last year it became open source. And they created it to handle Meta's monorepos, because they do all kinds of stuff in a monorepo. An existing version control system couldn't manage it efficiently. So it's able to handle very large repos. According to the Sapling documentation, tens of millions of files or commits or branches can be supported by the system. But there is a small caveat, and that is that they didn't make all components open source. So they open sourced the version control system, but the virtual file system and the Sapling server that they also use to be able to support those very large monorepos, they didn't open source them. So if you would want anything, you want to try this for a very large monorepo, you would still have to use those systems, and they're not open source. So that is a drawback for popularity, I guess. In Sapling, local branches are optional. You can create stacks of commit, just like Git branches. But you don't necessarily have to add a label to it. You can, but it's not mandatory. And compared to Git, commands in Sapling generally do one thing. So Git has commands like checkout or reset that can do different things based on how you use them or what parameters you provide. But Sapling commands generally do a single thing. So they added a few commands compared to Git. So let's do also a quick demo of Sapling here. Let's just use this tab here. Okay. First, before I did the demo, I installed the GitHub CLI to make sure that this part is a bit faster. So if you would want to replicate this, you would have to install the GitHub CLI yourself and connect it to your own account. In this demo, I want to clone an existing repo, and it is a repo by myself that I use to store articles in. So I've written a few articles, one for the Dutch Java magazine, which is a magazine that is published on paper still. Very cool. And I've just cloned this repo. So I can just clone it with the SL command, with the Sapling command. I don't need Git for this. Let's see, we've got a readme.md, and we've got a directory that's called fish shell, because I wrote an article about the fish shell, which is also the shell I'm using right now. Let's just pretend we are also creating an article about Sapling, right? So let's create a Sapling markdown file like this, and then let's add that file to our repository. It has been added. Let's just ask about the status of our repository right now. I can see it has been added, right? Now I want to add a title to our markdown file, so this is the way I do that. And I can now just commit, add an article title. And if you ask for status again, we don't have any changes. So this is different from Git, right? When I want to add a file to the repo first time, I use the add command. But when I then edit it, edits automatically end up in your commit. So I don't have to specifically add my edits to known files. Sapling does that automatically. Just like Fossil, Sapling also comes with a web UI. Just want to start it up real quick. This is the web UI. It's called the Interactive Smart Log. You can see all kinds of stuff about your repository if you want. Of course, this one is not very interesting, but if you've got a large repository, it will probably be a lot more interesting. And now I want to, let's look at the log for now. So I've created one additional commit, right? 1st of June, it checks out. And now I want to submit a PR, and this I just can do from the sampling command line, because it has authenticated me through the GitHub CLI. It looks like we have created a pull request here, and with the smart log command, I can even see the status of my pull request. So if I would close it down or merge it right now via GitHub, I would see this status updated here if I would want to do that. So that's kind of neat that it seems to have native pull requests in your command line. Something that Git has always lacked, in my opinion. Are we seeing slides yet? Okay, no slides, that's not a problem. Let's see, how can I fix that? Yeah, this is where we were. Okay. Okay, back at the slide. So Git versus sapling. Like I said, local branches in Git are mandatory, and in sapling they are optional, so you don't have to specify it if you want. Didn't show it in the demo, but Git has a mandatory staging area, and in sapling, like I showed you, not for changes, so changes automatically get added. Pull behavior from remote, I told you this before, Git will by default pull all branches, and sapling will pull main branches only, unless you specify it not to, of course. So then we get to the predictions. Just a reminder of our prediction variables. These were the 5 prediction variables, and this is what I will do. I will score all systems according to these variables, give them a plus or a plus plus or a minus or a minus minus. All will add up to a total score, and then I will just guess what happens in 10 years, right? So let's talk about features first. Well, I think Pixel shows the most promise in the sense that it's really a different VCS with patches, which also means that people will not get stuck in their repositories anymore. So I think that feature is quite unique and really can help people along. I like a few UX things that Sapling did, but they are not really groundbreaking, right? And Fossil has the web UI and has the descendants and ancestors thing. So that's kind of nice, but not really groundbreaking in my opinion. Then about hosting, of course, Git and to a lesser extent Mercurial win this one because hosting for Git is superb. There are 18 different websites that provide hosting capabilities for Git. There are currently 7 that do the same for Mercurial. Mercurial, Team Foundation, well, it's just Azure DevOps and it's mostly private repos, so not a good score there. Fossil has Chisel, Pixel has the Nest, and Sapling also has a single one, but that happens to be GitHub, so that's quite a famous one. So gave them a point for that. Open source, I think Git and Mercurial are the clear winners here. They really have helped open source move along. I don't think Fossil is the best on this one because it's focused on small teams, so how can it then support open source? It's kind of a mismatch there. I think Pixel has some potential here, and Sapling, I thought it would have potential, but then they kept a lot of things closed source that they maybe should have open sourced in order to make it more popular. Because why would I switch to Sapling when I have a large monorepo, but don't have all the tools to efficiently run it, right? So that's kind of a pity. IDE support, very important. Of course, Git and Mercurial support is superb. I've looked into the rest of the systems, and the extensions, the plugins for Pixel are quite outdated and they're not maintained anymore. And for Sapling, there is an official plugin for VS Code, but there's not one for IntelliJ or Visual Studio, so that's kind of a shame. And for Fossil, there was a good IntelliJ plugin for Fossil, but also not very good maintained. So not very good scores for the new ones here, and that's kind of makes sense because didn't have much time to catch up the plugin development. And the dominant products will suffer from this one the most. So Git and Mercurial gave some minus points, and the rest is at 0. And when I then add all the points up, it seems like there's not really a single system that is going to win here. I mean, Pixel has some good stuff, but then the hosting support is very limited, so how can it become popular anytime soon? And Git and Mercurial actually are doing quite well in this table. So that is actually my conclusion. There is not a single version control system here that ticks all these boxes, right? If there was one that ticked all these boxes, I will tell you here right now, the best days of Git are over. But I don't think it is, because there are a few new systems, but they are not really ticking all the boxes, like I said. They are doing one thing better than Git, and the other system is doing another thing better than Git, but not everything at the same time. So let's put some percentages, because that's what I promised you. I think it will look something like this. I've highlighted the new systems here, right? I think they will gain some traction, but not very much. And if I would have to choose, I think that Pijol shows the most promise, but of course the hosting capabilities would have to improve to increase this 5% that I've guessed here even more. And I think that the basis of course, Mercurial will still decrease a bit, because it's been decreasing ever since, and Git will probably be stuck around 80% or something in the next 10 years. I've sorted them by popularity, and then you can see that Git will remain on top according to what I see right now, according to the data that I have right now, right? But a lot can happen in 10 years. Maybe a new version control system will take the market by storm. But the systems that are currently being developed, I don't really see them catching up to Git anytime soon. That being said, I thought it was a real pleasure to check them out, and I think it's a good idea to just try some of these systems out in a hobby project or something like that to see if you like them. So if you liked the talk, you can read these articles to do some further reading about each version control system. I've listed one, and I will also tweet the slides, so you can follow these links if you want in your own time. And now what? What do you then need to do with this conclusion? Well, this is my advice to you. If you are working on a project that is nothing like the Linux kernel, so that is small and people know each other, it could be fun to try Fossil for a change and see if you like it and see if it helps you in your workflow. And if you encounter problems in your team, like Git snapshotting is way too technical and we end up with a lot of repositories that don't really get to be fixed anytime soon, try Pijol for a change, and it might even benefit you. And finally, if you want to try a new VCS, but you still need to use GitHub, then Zeppelin is a good choice because it integrates with GitHub and you can still use those repositories right there. I hope I inspired you today to try something new and to, like me, get interested in the things that are going on in version control world. If there are any questions, I think we're out of time, but you can come up to me or ask them online later. The slides will be here, and well, you can find me around. Thank you for listening and enjoy your evening. Thank you.